Number 13, we're trying to find missing side lengths, A and B in this case, for this specific type of special right triangle, which is a 45, 45, 90 degree triangle. And really, we can't do that unless we remember how these sides compare to one another and the formula that goes along with it. In a 45, 45, 90 degree triangle, we need to remember that the hypotenuse is the same as one of those legs times the square root of 2. So we need to set that equation up, and then we can plug in values that we know. Okay, so let's take a look at this. The triangle is a right triangle, and the hypotenuse across from that right angle is 9. So I'm going to plug in 9 as my hypotenuse. My legs that I've got listed as A and B are going to be the same because it's an isosceles triangle, right? So it doesn't really matter if I'm solving for A or solving for B. It's going to be the same value. Let's just plug in A. I don't know what A is yet as a leg, but I know A times the square root of 2 will get me 9. So I want to now just do the algebra to isolate A and get it by itself. Since it's being multiplied by the square root of 2, I'm going to divide by the square root of 2 to kind of undo that so those cancel out. But if I do that on one side, I've got to do it to the other side. Okay, so these cancel out like I want them to. I've got A all by itself. On the other side, I've got 9 times the square root of 2, which is kind of weird because we've got the radical in the denominator. To not change the value of it, but to show it in a different way, we're going to multiply it by the square root of 2. It's hard to see that in there. Square root of 2 over the square root of 2, which is really just 1. We're multiplying this thing by 1, but we're doing it in a way that's going to allow us to kind of change how that looks. So now I've got, I'm just going to bring down my A. In the numerator, I've got 9 times the square root of 2. And then in the denominator, I've got square root of 2 times square root of 2, which is 2. Okay, so it still looks kind of messy, but at least we don't have a radical in the denominator. And I've now solved for what this side length is. And I could say that's also equal to B, because A and B are the same, so I also know what B is going to be.